great strength of Hadoop is the ability to work with different types of data, where HDFS can store logs and many other data from variety of sources. MapReduce can parse and diverse various data formats and extract useful information from it. But to interact with data in various repositories outside the HDFS, Hadoop uses external APIs to get to this data. Often, in any organization, data is present as structured data, usually in the form of RDBMS. To get this data into HDFS, Hadoop uses Sqoop. So, Apache Sqoop is an open source tool that allows users to extract data from various structured data stores into Hadoop for further processing. This processing is done through MapReduce or other high-level tools like Hive. In this section, we'll look at Apache Sqoop, how it works, and how we can use it for our data processing pipeline. So, Hadoop as well as Sqoop both are written in Java, and Java has an API to access data stored in RDBMS. It is called Java Database Connectivity or JDBC. And Sqoop uses JDBC API for importing data from RDBMS. So let's say if we have a table named as department, and this department table has two columns. One is department underscore ID and another is department underscore name. And these columns have some data types. Like for department underscore ID, we have data type as integer. And for department underscore name, we have varchar data type. Now what Sqoop does is, before starting any import, it retrieves list of all the columns and their SQL data types, like we have here, department underscore ID, department underscore name with integer and varchar as data types. So Sqoop retrieves list of all the columns and their SQL data types. These data types are then mapped to Java data types. How? So for integer data type, we have int as our Java data type. Same way, for varchar, we have string. Then Sqoop's automatic code generator uses this information to create a table-specific Java class. Like to import our departments table, it will generate methods in that class, like for getting department underscore ID, it will generate a method something like this: public integer department underscore ID. For our department underscore name, it will generate a method like department underscore name. So these are the two methods Sqoop's automatic code generator has generated. Now public integer department underscore ID will fetch first column. Public string department underscore name will fetch second column. Now JDBC has an interface called result set. So JDBC's result set interface retrieves the records from the table by populating a query like select star from departments. Fine enough. It's a simple SQL query to fetch all the records from departments table. But For better import performance, Sqoop splits the table and launch parallel map tasks to import records. By default, it splits the records into 4 chunks. This splitting is usually done by primary key in the table. So for example, in our departments table, suppose we have 100 records and primary key is department_ID. Let me open another screen. So Sqoop will split our department table this way. From department_ID, which is our primary key. So from department_ID 1 to department_ID 25. It will generate one map task for department_ID 26 to 50. It will again generate one map task. Same way for department_ID 51 to 75. It will again generate one map task. And fourth split will be department_ID 76 to 100. Again, it will generate one mapper task. So this is how Sqoop splits the table based upon primary key. And then Sqoop will run mapper task by giving this query. Select star from departments where department_ID greater than or equal to 1 and department_ID is less than or equal to 25. And so on for our other splits. Like for this split, minimum value will be 26, maximum value will be 50. Then for third split, minimum value will be 51 and maximum value will be 75. For the fourth split, minimum value will be 76 and maximum value will be 100. These Sqoop queries are called boundary queries, and these values, minimum and maximum values, are called boundary query values. And we can change this number of mapper tasks with an argument like -m or --num mappers, and then we specify some number. Suppose we want 2 mapper tasks, just 2 splits, so we can provide 2 here or 2 here. It will become more clear when we will be seeing hands-on on Sqoop imports. Now another thing is, currently Sqoop does not split on multi-column indices or multi-column primary keys or no primary keys at all. We have to manually split the columns by providing another argument, which is split by. We are going to check these arguments and many more in our hands-on Sqoop import sessions.